Imagine Earth as a newborn, still sizzling from its fiery birth. Volcanoes rage, spewing lava and gases into the sky. Lightning dances across a tumultuous sky. The oceans still forming, churn and roar. This was Earth billions of years ago, a place of intense energy and constant upheaval. Yet within this chaos, the stage was set for life. The planet was cooling, and the first oceans were forming. Volcanoes and hydrothermal vents released chemicals into the atmosphere and water. These chemicals, the building blocks of life, would soon combine in unexpected ways. As millions of years passed, the Earth's surface began to stabilize. The constant bombardment from space lessened. The primordial oceans, vast and warm, became the cradle for life's first whispers. The early oceans were far from ordinary. They were a primordial soup teeming with simple organic molecules. These molecules, the building blocks of life, formed spontaneously from the chemical reactions fueled by the sun's energy, lightning strikes, and geothermal heat. Imagine these simple molecules bumping into each other in the primordial soup. Over eons, some of these collisions resulted in more complex molecules like proteins and nucleic acids. These larger molecules, essential for life, began to assemble. A critical moment arrived with the formation of the first cell membrane. This protective barrier, perhaps a simple fatty layer, enclosed a tiny droplet of the primordial soup. This isolated environment was crucial. It allowed the molecules inside to interact more efficiently and replicate, setting the stage for the first true cells. The first life forms were single-celled microorganisms, simple prokaryotes. These pioneers thrived in the harsh conditions of the early Earth. Without oxygen to breathe, they extracted energy from the chemicals abundant in their surroundings, like sulfur and iron. These early microbes were incredibly diverse. Some lived in the depths of the oceans, near hydrothermal vents, drawing energy from the Earth's heat. Others inhabited shallower waters, using sunlight to produce energy through a process called photosynthesis. Though simple in structure, these early prokaryotes possessed the remarkable ability to reproduce. They were replicating themselves, passing on genetic information from one generation to the next. Life had gained a foothold and begun its incredible journey of evolution. Section 4. A tapestry of microbes. Diversity in the depths. Within the early oceans, a hidden world was flourishing. Microbial communities, invisible to the naked eye, were evolving and diversifying at an astonishing rate. These single-celled organisms were the architects of Earth's early ecosystems. Some microbes became master recyclers, breaking down organic matter and releasing nutrients back into the environment. Others formed symbiotic relationships, living in close cooperation with other organisms. The oceans were teeming with a hidden diversity, a tapestry of life woven from microscopic threads. This microbial world was not just diverse, but dynamic. New species emerged through random mutations in their genetic code. Some mutations proved beneficial, allowing the microbes to adapt better to their environment. Natural selection favored these advantageous traits, driving the evolution of new life forms. Section 5. The Oxygen Revolution, a turning point. One of the most significant events in Earth's history was the emergence of oxygen-producing photosynthesis. Certain microbes, called cyanobacteria, evolved the ability to harness sunlight to split water molecules, releasing oxygen as a byproduct. This innovation would forever change the planet. Oxygen, initially toxic to most life forms, began to accumulate in the atmosphere. This oxygen revolution was a double-edged sword. It led to the extinction of many anaerobic microbes, unable to cope with the reactive gas. However, it paved the way for a new era of life. The rise of oxygen allowed for the evolution of more complex life forms that could utilize this gas for energy. This crucial step set the stage for the development of multicellular organisms, the ancestors of all plants and animals that would eventually populate the Earth. Section 6. A legacy of innovation, life's enduring impact. The story of life's emergence is a testament to the power of innovation and adaptation. From the chance assembly of molecules in the primordial soup to the evolution of oxygen-producing photosynthesis, life has continually found ways to thrive in a changing world. Even today, billions of years later, microbial life continues to shape our planet. They are the unseen engines of ecosystems, driving nutrient cycles, breaking down pollutants, and even influencing our climate. Their enduring legacy reminds us that the spark of life, once ignited, has an incredible capacity for resilience and creativity. As we explore the universe searching for signs of life beyond Earth, we carry with us the lessons learned from our own planet's history. Life, once thought to be rare and precious, might be more common than we ever imagined. Perhaps somewhere in the vastness of space, another primordial soup is brewing, ready to embark on its own extraordinary journey.